Welcome to the world of machine learning. This field empowers computers to learn from data, making intelligent predictions. We'll predict survival outcomes from the Titanic disaster. Don't worry if you're new to programming, we'll guide you. Imagine a dataset with information about Titanic passengers. Our goal is to build a model to predict survival likelihood. This project is a great starting point for machine learning. We'll use Python and Scikit-learn, ideal for beginners. Get ready to unlock the potential of data with machine learning. Before we dive into machine learning, let's ensure we have the right tools. Our weapon of choice is Python, a versatile and beginner-friendly language. Python's clear syntax and extensive libraries make it a favorite among data scientists. We'll use Scikit-learn, a popular machine learning library for Python. Scikit-learn provides a user-friendly interface for building models. We'll use the Titanic dataset containing data about the passengers. With Python, Scikit-learn, and the Titanic dataset, we're ready for our machine learning adventure. Let's set up your Python environment. If you're new to Python, don't fret. It's incredibly easy to get started. Download the latest version from the official Python website. Follow the installation instructions. Next, install Scikit-learn using pip install Scikit-learn. Also, install pandas and NumPy for data manipulation and numerical operations. With these libraries, we're ready to write some Python code. With our Python environment set up and libraries installed, let's start by importing the necessary modules into our project. Imagine these modules as specialized toolsets, each containing pre-built functions and tools to help us with specific tasks. First, we'll import pandas, our data manipulation library. Using the keyword import followed by the library name, we bring in the pandas toolkit. We use as PD to create a shorthand alias for pandas, making our code cleaner. Next, let's import NumPy for numerical operations. NumPy provides powerful tools for working with arrays and matrices, essential for handling numerical data in machine learning. Finally, we'll import specific modules from Scikit-learn for our model end. These import statements bring in the necessary tools for data manipulation, numerical operations, splitting our data, and implementing the logistic regression model. Think of it as gathering all the ingredients before starting a recipe. Now that our tools are ready, we can move on to loading and exploring our Titanic dataset. Section 5 Titanic Dataset, a deep dive into data. Let's load and explore our Titanic dataset. Use Pandas' read_CSV function to load it into a data frame. A data frame is like a powerful spreadsheet within our code. Peek at the first few rows using the head function. This shows the data structure and information for each passenger. Columns include survived, class, sex, age, and more. Use the info function to get a summary of our dataset. This helps identify data types and potential missing data issues. Understanding data structure is crucial before any machine learning task. Data exploration is like detective work. Thorough understanding guides our model building process. Section 6. Data wrangling, cleaning, and preparing for analysis. Now that we've explored our Titanic dataset, it's time to roll up our sleeves and do some data wrangling. Data wrangling involves cleaning and preparing our data to ensure it's in top shape for our machine learning model. Think of it as preparing the ingredients before cooking a delicious meal. First, we need to address any missing values in our dataset. We can use various techniques such as imputation, where we replace missing values with estimated ones. For example, we could replace missing ages with the median age of passengers in the same ticket class. Next, we'll convert categorical features like sex and embarked, port of embarkation, into numerical representations. Machine learning models typically work best with numerical data, so we'll use techniques like one-hot encoding to transform categorical values into numerical ones. Data wrangling ensures that our dataset is consistent, complete, and ready for analysis. It's a crucial step in the machine learning process, as the quality of our data directly impacts the performance and reliability of our model. Section 7. Feature engineering, selecting the right tools. With our data cleaned and prepped, it's time for some feature engineering. Feature engineering involves selecting, transforming, and creating relevant features from our dataset to improve our model's performance. Think of it as choosing the right tools for the job. In our Titanic dataset, we have features like age, sex, and PC class. We can create new features that might be more informative for our model. For example, we could create a new feature called family size by combining the number of siblings, spouses, and parents, children a passenger had on board. We can also transform existing features. For instance, we could create age groups from the age feature, categorizing passengers as children, adults, or seniors. Feature engineering requires creativity and domain knowledge to identify features that might be helpful for our model. By carefully selecting, transforming, and creating relevant features, we aim to provide our model with the most informative and discriminative information possible. This step is crucial for building a model that can effectively predict Titanic survival outcomes. Section 8. Logistic Regression, Unveiling the Power of Prediction. Now it's time to choose a machine learning model for our Titanic survival prediction task. We'll be using Logistic Regression, a powerful algorithm well-suited for binary classification problems, where the outcome is either one thing or another, like surviving or not surviving. Logistic regression works by finding a relationship between the features and the probability of belonging to a particular class. In our case, it will analyze features like age, gender, and ticket class to estimate the probability of a passenger surviving the Titanic disaster. We'll use the Logistic Regression class from Scikit-learn to implement our model. We'll first create an instance of the model and then train it using our prepared Titanic dataset. Think of training a model as teaching it to recognize patterns and relationships within the data. Logistic regression is a widely used and well-understood algorithm, making it an excellent choice for beginners in machine learning. Its ability to handle both numerical and categorical features and provide probability estimates makes it a versatile tool for various classification tasks. Section 9. Training the model. Teaching our machine to learn. With our logistic regression model set up, it's time to train it using our prepared Titanic dataset. Think of training a model as teaching a student using a textbook. We feed the model our data, and it learns the patterns and relationships within the data to make predictions. First, we'll split our dataset into two parts, a training set and a testing set. We'll use the training set to teach our model, and the testing set to evaluate its performance on unseen data. This ensures that our model can generalize well to new, unseen data. Next, we'll use the method of our logistic regression model to train it on the training data. During training, the model adjusts its internal parameters to minimize the difference between its predictions and the actual outcomes in the training data. Training a machine learning model is like coaching an athlete. We provide the model with data, guide it with an appropriate algorithm, and let it learn from its mistakes to improve its performance over time. Section 10. Model Evaluation. Assessing the accuracy. Now that our logistic regression model is trained, it's time to evaluate its performance. Model evaluation involves assessing how well our model can predict Titanic survival outcomes on unseen data. Think of it as grading a student after they've studied the material. We'll use our testing set, which our model hasn't seen during training, to evaluate its performance. We'll use metrics like accuracy, precision, and recall to measure how well our model predicts survival outcomes. Accuracy tells us the overall correctness of our model's predictions. Precision measures the proportion of true positive predictions, correctly predicted survivals, out of all positive predictions. Recall, on the other hand, measures the proportion of true positive predictions out of all actual positive cases. Model evaluation is crucial for understanding our model's strengths and weaknesses. By analyzing its performance on unseen data, we can identify areas for improvement and fine-tune our model to make it even more accurate and reliable. Section 11. Charting your course, exploring new machine learning horizons. Congratulations on building your first machine learning model. You've taken a deep dive into the world of data science, from setting up your environment to training and evaluating a logistic regression model to predict Titanic survival outcomes. Remember, this is just the beginning of your machine learning journey. There's a vast ocean of knowledge and exciting projects waiting to be explored. Consider experimenting with different machine learning algorithms, such as decision trees or support vector machines, to see how they perform on the Titanic dataset. Explore other datasets, tackle new challenges, and never stop learning. The world of machine learning is constantly evolving, with new techniques and applications emerging all the time. Embrace the challenge, and who knows what incredible insights you'll uncover. As you delve deeper into the world of machine learning, remember that every expert was once a beginner. Embrace the learning process, don't be afraid to experiment, and most importantly, have fun exploring the fascinating world of data science.